Alrighty, welcome to Chapter 5, Section 5.2, Multiplying and Dividing Radical Expressions. So before we just learned how to add and subtract, remember, adding and subtracting, right? Something like 2 root 2 plus 3 root 2. These guys need to be the same. This would be 5 root 2. Okay, same thing with subtraction. In this case, you're going to need the same index, okay, the same index for multiplication only. So basically all you care about is the index. Okay? The insides, the radicand, can be totally different, but if the index is the same, then you're going to go ahead and multiply them in this manner. So take a look at this example right here. 2 root 7 times 4 root 75. Basically, you're going to multiply like terms. So 2 times 4, they're both integers. They are multiplied by each other right here. Then 7 times 75 will be done underneath the same radicand sign. Radical sign. That's why the index is all you need to be the same. Then, after that, it's just simplification, right? This is the only new step in this section. This, and we're going to talk about division. But in multiplication, this is the only new step. After that, this is all simplification. Okay? Let's do some examples. Once again, I worked these out for you. Read through them. Hopefully you've already read through them. This is more of a refresher. If you're confused, I'm going to do absolutely identical questions. And then it would be a good exercise to go back and take a look at these. Okay? So, if I can actually go on. There we go. Multiply and then simplify where possible. So let's start right from the start. 5 root 3 times root 6. Same index. What's the index? That would be, of course, 2. Right? There really is no integer here. This is 5 times 3 times 6. Right? You don't have to do the step. Okay, you could, in this situation, you could go right to it. Root 3 times root 6 is root 18. But this is certainly able to be simplified. So maybe I'll just erase. There we go. So we get 5 times root 18. Okay, that's the multiplication step. Right, that's the multiplication step. Now we're going to simplify. Now we're going to do our simplification step. Simplify. And we're going to do, I can see that 18 is 9 times 2. So really we have 5 times 9 times 2 under the square root sign, which will be equal to 5 times 3 root 2, which is equal to 15 root 2. Right. It's kind of cool. Good exercise. Type this in your calculator. 5 times root 3 times root 6. Then type in 15 times root 2, and you should have the same decimal expansion. If you don't, then I made a mistake, or you made a mistake typing it in. So, here we go. This next one looks absolutely ugly, but the same indice, 3, 3, 3. Therefore, we can multiply across. I'm going to distribute this guy in. So negative 2 times negative 2 times 4 is negative 8. Then what we have is we have cube root 11 times 2. And we're going to have plus 6, because negative 2 times negative 3 is 6. Cube root 11 times 3. Now we actually, this is addition, as you can see. This is addition, which means we actually will require the same radicand underneath the radical sign. Okay, so there's your, if you practiced a lot in the previous section, that should have been clear to you. So here we go. Here we go. We're going to go negative 8. Cube root, this is 22, plus 6. And this is cube root 33. Now what can we take out of both of these guys? What can we take out of both? If anything. And really, the only thing you can take out of 33 would be 11, just like we got here, and then 2 would be the only thing, right? 4 doesn't go into 22. Obviously, there are no odd perfect squares that go into 33, so I'm going to declare this as simplified. Okay? Now let's go to C, sorry. In this one, you have 2 binomials multiplied. The only option here is to distribute, okay? Distribute these in. So we have 4 times root 2, and I'm going to show my work, times root 7. That would be the first term. The next term would be negative 20. Okay, 4 times negative 5, right? Then you have root 2 times negative 14, right? I'm distributing the second term there. Now we're going underneath here. We're going to have plus 4 times root 2 times root 7. Basically the same. Sorry, of course not basically the same. I made a mistake. You're going to go 3 times root 7. And you're going to get 3 root 7, and then you're going to get negative 15 times root 14. Okay? So, to simplify this, root 2 times root 7 is going to be root 14. So you're going to be left with 4 root 14 minus, now root 2 times root 14 is root 28 plus 3 root 7 minus 15 root 14. Right away we can actually subtract these two terms right here. Okay, and these guys right here. Let's do that subtraction. 4 minus 15 is negative 11 root 14. And I guess we can do a couple things in this step here. We could divide 28 by 4. That actually gives us 7. So we can actually make this 4 times 7. Yeah, and that's going to give us, that's going to make us be able to pair up these two guys. Okay, and these guys. Okay, let's keep going. We're not done yet. I think root 14 will be as simplified as it can get. But this one will come out to be 2 root 7 plus 3 root 7, which equals, so you're going to have negative 11 root 14. And then you're going to have plus root 7. That might be the limit. Okay, there are no perfect squares that go into 14. Okay, and I think that's it. That would be the end. Okay? Now, I'll let you look at that for a second before I erase this. We're going to move on to D. D looks a bit ugly. Maybe I'll start it up here. So in D, you're going to distribute just like B. It's actually almost pretty much the same question. So in this case, you're going to have negative 8. Okay, and then you're going to have square root, and this is why it's just a bit ugly, because you have all this inside business. 11c times 2c cubed. Okay, then you have plus 6, right? I'm distributing this over here now. So negative 2 times negative 3 is plus 6. Then you have a square root, and it's going to be 11c in the middle times 3. Okay? Now, we are going to simplify. So, 11 times 2 is 22. This is c to the 4. The next, there we go, plus 6 times 11c times 3, that's 33, 33c. And we're pretty much left in the same situation as before in B. Look at that. Very similar questions. Okay, almost identical questions. And we've been through this battle before. There is nothing we can take out of here that I can see. And so we are done. Very short. Okay, so that's basically half the video, half the name of the game. That's multiplication. Now let's move to division. Division is pretty much the same thing. You need the same index. Okay, so but basically in this case you're going to divide the coefficients first. So you can see that 4 divided by 2 would be 2. That's why we get that over there. What do you think that's going to be? 6 divided by 3 is 2. And then you just carry that radicand sign over there, the radical sign. Here's a more explicit procedure what you're doing. But this one worked out very well. Okay, sometimes you can get this situation where you're going to have a square root on the bottom. Okay, 1 over square root 2, for instance. In this case, when you simplify it, we're going to try to remove the radical from the denominator. This is complete math convention. Okay, so it's notation only. Okay, it's actually perfectly legal to square root, to have a radical in the denominator. Definitely legal. Your calculator will be able to compute it. There's actually some massive benefits to leaving it in this form. For instance, if you're going to work with the unit circle, 1 over root 2 is probably more intuitive than if you rationalize this. Rationalizing it will mean removing root 2 from the bottom, but I'm going to have the same expression. It'll have the same decimal expansion. In this case, all I would do here is I would multiply top and bottom by root 2. This would give me root 2 over 2. These two guys are the exact same, but in this guy right here, the square root's on top. That's the only difference. So I'm going to teach you, or I'm going to have you guys learn this procedure. The procedure is useful, okay, in some applications in calculus and in differential equations. Sometimes you actually have to do this to get things in the right form. But keep in mind that both forms are actually useful depending on your application. In the unit circle, I prefer it like this. You actually kind of lose a bit of information when you move away from that form. But it's the procedure that's definitely important. Okay, so when you're working with monomials, that means one term, which is what I just did. Basically, I just multiply the top and bottom by whatever the term is when it comes to square roots. But when it comes to higher indices, you're going to see what we're going to do. For binomial, you're going to have to use something called the conjugate. Okay, so we'll start with case 1, monomial radical denominator. This looks ugly. Read through it. Okay, read through it carefully. But it's quite intuitive. Here's a question that you can be given. To get rid of that root 3, just multiply top and bottom by root 3. Simplify. These are the same things. They look kind of different, eh? Same decimal expansion. Type it in. But say it's an odd, or say it's a different indice than 2. Cube root 3 times cube root 3 is not 3. I'm sorry, it's not 3. You need another one. These 3 together equal 3. That means you're going to have to basically take a look at your indice, and you're going to have an exponent that will be 1 less than it. Okay. This little general form holds true for this one as well. Okay, the indice here is 2, so technically I squared this. Sorry, technically my exponent's 1 here. Okay, so I came up with this little algorithm for you. So if you want to get rid of a monomial radical in the denominator, you're going to multiply both sides by the same thing to the power of 1 minus it. Okay, or k minus 1 if your index is k. And that will remove the radical from the denominator. If, however, you're dealing with a binomial, then you're going to have to use something called the conjugate, which is quite simple, and it takes advantage of a difference of squares. Take a look at this example. Okay, I only have one because there's really only one option. To get rid of this, okay, I can't multiply top and bottom by root 6 because that would distribute to this 4 and you'd be left with 4 root 6. While this would be 6, this would be 4 root 6, so it's kind of a waste of time. But in this one, you're going to distribute if you multiply by the same term except changing the sign. What you're left with here is you're going to be left with a difference of squares when you distribute it. Okay, take a look at that. Which will reduce to give you no radical in the denominator. Okay, so it's a very clever idea. Here is kind of the general form, and this will be using square roots. Okay, so same thing. Let's start with a. We have 2 root 51 over root 3. In this case, you have to go right ahead and multiply top and bottom by root 3. Okay, it's the only way you're going to be able to get rid of this guy. Unless there's some kind of clever way by rewriting 51, but we might as well just do this. Okay, 51 times 3 is 153, so we have square root 153 over 3. Now, can you simplify 153? Okay, you can totally do that. If you divide it by 9, which is the first thing I checked, because it's odd, so the first perfect square that's odd would be 9. And you get 17 on the bottom. So this is the same thing as say 9 times 17 times 3, which will come out to be, take that out, 3 times 2 is 6, so it's 6 root 17 over 3, which will come out to be 2 root 17. That simplifies quite nicely. This next one, for part B, you're going to have to do the exact same thing, except it is a cube root. So how do you work with this guy? You work with it in the same way, except remember, you're going to multiply top and bottom by whatever you want to get rid of, all to the power of 1 minus whatever you're working with. In this case, it would be 2. 3 minus 1 is 2. On the top, you're going to be left with exactly what you multiply by. Okay, which is that. And on the bottom, you're going to have 2 times 9p, which comes out to be, the top just won't simplify. Okay, so here's where sometimes when you rationalize, you get an uglier value. Okay, but that's the best we can do here. And that is the answer. Okay. Typically in these situations when the indices is 3, okay, it's hard to simplify the top like that. Okay, this one didn't reduce too well. Number letter C. Looks quite basic, doesn't it? Looks quite easy. But since you have a binomial in the denominator, you're going to have to multiply by the, you guessed it, the conjugate. The top, again, you're going to have to distribute. I'm starting to get lazy here with my writing. Okay, distribute these guys in. And maybe I'll just write down this is the conjugate. Okay, so this will come out to be 6 root 5 plus 8 on the top, and on the bottom you can go through the whole distribution, or you can remember that basically what you're gonna be left with is the square of both these terms. Okay, separated by a negative sign. So basically what we're gonna be left with here is it's gonna be 9 times 5 minus 16, right? That's when you take a look back at your notes, right? Take a look back at your notes. You're always left with a negative sign in between. Okay, and what you're doing is you're going to square both sides, both terms. So here we have 6 root 5 plus 8 over 9 times 5 minus 16, which is 29. And you could take out a 2 from this term, but that would just work backwards. You'd be left with this. So let's just keep it like this. Okay. I believe that's probably how I left things. Things worked out well up top here. And the last question, question D, is essentially the same question. Right away, you should immediately tell what case you're with. Here is this is a binomial, so you already know you're working with case 2 here. Once again, this time you're going to have subtraction in your conjugate. So in this case, you're going to be left with 6 root 4x minus 6 all over. When you square root 4x, you just get 4x, and you're going to have minus 1. Okay? Now that's basically it. Okay, this guy can't simplify any further than that. Okay, you could really leave the 6 out of the top, but there's no need for that, and you can get clever by pulling this 4 out, but let's not worry about that. That's when simplifying goes crazy. Okay, and this is good enough. So hopefully you get the idea of using the conjugate. Okay, hopefully you can read my writing here as I go through. If you follow along step by step, things should make sense. Work on the practice problems, and then when you're ready, move on to section 5.3.